Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, today we're gonna solve this question. Okay, solve the last part of this question. Okay, so if you have missed the previous solution, don't worry, I'll put the link to the previous solution at the end of this tutorial. Okay, until then, stay with me, please stay with me fellas. Okay, now let's read the question. The question says the infrared spectrum of one of these compounds is given below. So here uh, the infrared spectrometry is given over here. Okay, here this is transmittance in this column, and in this column excuse me, in this column the transmittance is given, and in this column the wave number is given per centimeter. Okay, they have given some data over here, as you can see. So let us analyze the data. So here the bond is given, the type of bond is given here. This is hydroxyl group of alcohol which has a wave number range between 3750 to 3200. Alkane, this is CH bond of alkane which lies between 2962 28 53. Okay, and this CH bond of aldehydes lies somewhere between 2900 to 2820 and 2775 to 2700. Okay, and this CO group of, it might be aldehyde or ketone, okay, which lies between the wave number range 1740 to 1680. Okay, so now let's read the question, what it has asked. The compound with this infrared spectrum is propan-1-ol, propan-2-ol, propanal, or propanon. Okay, well fellas, before answering this question we need to determine what type of peak does this individual bond gives. Okay, so in here, in the case of alcohol, we are expected to find a broad peaks. Okay, broad peaks. Okay, and this gives nothing, normal things, not abnormal things. Okay, this two gives normal things. So these three gives, as you can see here, there is no carboxylic acids data given. For the case of carboxylic acid, the peak should be very broad. Okay, if you have remember that in the case of carboxylic acid for OH, since it has contains OH and CO, so it will give very broad peaks for carboxylic acid. Since carboxylic acid is not given over here, so we don't even bother about carboxylic acid. Okay, we just gonna leave that behind. Okay, so in this case over here, alcohol will give broad peaks. Okay, and other will give what, these two will give the normal things, and this CO of aldehyde and ketone will give very sharp peaks. Okay, very sharp peaks. Okay, so here, as you can see here, let me summarize this thing once again. So for an alcohol, okay, for an alcohol, for the bond of alcohol, we are expected to find broad peaks around this range. Okay, for alcohol we are expected to find broad peaks around this range. Okay, and for aldehyde or ketone, okay, we are expected to find very sharp peaks around this range. Okay, am I clear? I hope so. So in here, let us analyze the data given, the infrared spectroscopy given. So in here, as you can see that since there is no broad peaks present over here, so this wouldn't be the data, this wouldn't be the spectroscopy for alcohol. If this was the spectroscopy for alcohol, there would be broad peaks present. There would be broad peaks would be present. Okay, broad peaks would be present over here. Okay, so if this was for alcohol, the broad peaks would have present. Okay, since broad peaks are not present over here, so alcohol, this is not alcohol. Okay, this is not alcohol since broad peaks are not present over here. Since these are all sharp peaks, so here as you can see that here we have sharp peaks at around 1740 to 16 something, 16 here at around here to here. So in this range we have found a very sharp peak. Okay, so this is the range around 1740 to 1680. So this lies in the range of 1740 to 1680, and we have found that at this range we have found a sharp peak, a very sharp peak. So this symbolizes that this compound would be either aldehyde or ketone. Okay, this should be either aldehyde or ketone. So now let's get back to the question. The compound with this infrared spectrum is propanol, propan2ol, propanal or propanon. Okay, so let's match this thing with the data given. Since there is no broad peaks, so alcohols are not the answer. Okay, since broad peaks are not present, this shouldn't be the answer. Okay, since broad peaks are not present. Okay, since broad peaks are not present in the infrared spectroscopy, so the alcohols aren't the answer. So we're gonna leave A and B. So now the question arises between C and D. Since these both give very sharp peak at the same range here, as we can see here that these both give this aldehyde or ketone. This propanol is aldehyde. Let us know that this propanol is aldehyde, and this propanon is ketone. Okay, this propanol is aldehyde and this propanon is ketone. Okay, so since this is aldehyde and since this is ketone, so they are expected to give very sharp peaks. That's really fine. Then what should be the answer? We can choose both of the option. Either of them should be the answer. Either this or this should be the answer. Any one of this should be the answer, right? Yeah. So here, so what we are left here with is the carbon hydrogen bond. Okay, now we are going to examine carbon hydrogen bond. Okay, before we were examining the carbon oxygen bond of aldehyde and ketone. Okay, the carbon oxygen bond, this particular carbon oxygen bond of aldehyde or ketone, okay, gives a very sharp peaks at around this range. Fine. So we are in a state of confusion whether this or this should be the answer. Now let's look out for the carbon hydrogen bond. Okay, so this is for carbon hydrogen bond for alkane and this is for carbon hydrogen bond for aldehyde. So if there is any peak around this range, then aldehyde would be the answer. Okay, now let's look out for this peak, aldehyde, carbon hydrogen bond for aldehyde. So let's look around 2900 to 2820 and this. Okay, so let's have a look. Okay, uh, where is okay, around 2900 to 2800, let me mark this range around here, somewhere to here. Okay, now let's sum this range up. Okay, now let's summarize this range up. In here, uh, around this 2900 to 2700, there is no expected peak. Okay, around this wave number, since there is no expected peak over here, so this shouldn't be aldehyde. We are talking about aldehyde. Okay, so since there is no peak around this region, so this shouldn't be the aldehyde. So the only option here we are left here with is ketone. Okay, so ketone would be the answer. Okay, so why ketone should be the answer, why not aldehyde is not the answer? Okay, well, at first let me tell you that ketone would be the answer, not aldehyde. So ketone would be the answer, not aldehyde. Now let's discuss why ketone should be the answer, why ketone should be the answer, not aldehyde. Okay, so in here, as you can see that for CH bond, now let us look out for CH bond for aldehyde. Okay, so in here we can see that around this range there is no peak. Okay, so let me extend this thing up, then it would be convenient for you to understand. So around this peak, around this range, suppose this is the range, since there is no peak. Okay, since there is no peak, small peak, large peak, since there is no peak around this range. Okay, so around this range, so aldehyde is not the option. Since there is no peak for carbon hydrogen bond, so this compound shouldn't be the aldehyde. So the only option that we are left here is ketone. Okay, so that is why D is the answer, which is propanone. So uh, propanone is the answer. Now let us summarize this whole thing up. So propanone is answer because, okay, because the first point is there is no peak at around 2900 to 2700 for CH bond for aldehyde. Okay, and the second point is here, since there is no peak around this range, CH bond for aldehyde, so aldehyde is not the answer. So here the second point is since there is only because only very sharp peaks are observed. Only very sharp peaks are observed. Okay, only very sharp peaks are observed. Okay, since only very sharp peaks are observed, so this option should be ketone. Okay, since according to the information we have very sharp peaks around this range, since we have very sharp peaks around this range, so this option must be ketone. So ketone shouldn't be ignored. Okay, so fellas, I hope that you have understood the question as well as the solution. uh, the answer for this question is D. Okay, which is propanone. So propanone, therefore propanone is the answer. Propanone. Okay, therefore propanone is the answer. So fellas, I hope that you have understood the question as well as the solution. So if not, please let me know in the comment below. I'll be always there to help you out. So fellas, if you have missed the previous solution and you want the previous solution of this question paper, you may find somewhere over here. I'll put the link somewhere over here. Click the link, click here to find the previous solution, previous episode of this question paper, previous solution of this question paper. Okay, so fellas, was this solution helpful to you or not? Please let me know in the comment below, and please leave a feedback about this solution by giving a like or dislike. Okay, either of them will do. Okay, smash that like button or smash that dislike button, either of them will do. Okay, we offer you a like button or dislike button, the choice is yours. Okay, so fellas, that's the end of this solution. Stay cool, stay awesome, best of luck for your exam, and as always, peace with chemistry.